Hello everyone. I hope that you enjoyed the little quick video that I found about looking at quadratic functions and some real-world applications. Today we are going to work through some real-world applications and try to actually use real-world application to solve some of the same things that you've been working on algebraically. So I went ahead, if you want to go ahead into in Schoology and pull up the PDF of the homework for tonight, you can follow along and fill it in as we go. Otherwise, you could just watch and listen and go back later and fill in, but we are going to be working on some of the parts of your homework right now. I took the time to actually label your graph, which you might want to stop the video and do if you're following along, but we're going to relate it to actually what happens with a real life story problem. So when you have this quadratic function, it is a U or upside down U. Real world applications usually are flipped over. We still have our vertex, but in real world problems like a ball being thrown up in the air, it goes up and it comes back down. And this vertex is our highest point in our problem. Okay, so it's really the height the object will reach. Okay, so that's a pretty important point. Okay, we find that vertex, okay, we can find it algebraically in standard form or in vertex form. In vertex form, it's pretty simple because we just pick out h and k. So our vertex in vertex form is simply the opposite of h, or h, and then k. So that's our xy value of our vertex right here in vertex form. Now, for standard form, it takes a little bit more effort to find the vertex because first we have to find the x value, which is our same x value right here for our axis of symmetry. So our equation for our axis of symmetry in standard form is x equals the opposite of b over 2a. And so that is the same value, the x value of our vertex. So the y value of our vertex in standard form comes from, we have to plug in our axis of symmetry to find our y value. So that y value right there is also going to be our maximum value. So that's how we find it. It ends up to be our max value. So that's a pretty important point, and that is the highest point our object will ever get. So that maximum value is our y value when we plug in our axis of symmetry. So how do we find the axis of symmetry in vertex form? Well, I think it's easiest to find the vertex and then remember that the axis of symmetry goes through the vertex and it goes through at that x value. So our axis of symmetry is really whatever that x value is, and so it's the same as our x value right here in our vertex, so it's just x equals h. Our maximum value in vertex form, again, is the y value right here. And so it's the y value of our vertex. And so it's just going to be our k value. So our y-intercept. Our y-intercept here is the value of y when x equals 0. Well, that y-intercept really in standard form is just our c value. And in terms of our word problem or story problem, this is like our starting height. It's like our initial height. So if we start the object on the ground, then our y-intercept is 0. But if we start throwing it from like our shoulder, then our y-intercept might start at 5 feet above the ground. So that's the initial height where we start the path of trajectory. Now, when we look at the y-intercept in vertex form, in order for us to get our y-intercept right here, we would plug 0 in for x into our equation, and then we could get that y value. We haven't done a lot of that, but it certainly wouldn't be too difficult to do. And then last but not least, we have our x-intercepts. And in terms of the story, what happens is an object goes up and it comes back down. So this last x-intercept right here, when it comes back down, it is the time it takes for the object to get back to the ground. And sometimes this x-intercept over here is not applicable if we have a different starting height. So this would be when our x-intercept is negative. Then it really doesn't apply. So, how do we find those x-intercepts algebraically? Well, we have to put 0 into the equation for y, just like I said over for vertex form, and then we end up with having to use factoring, or the asterisk method, or the box method, etc., and the zero product property to solve. So we've already been doing a lot of the math and the algebra, but we've been doing it with just problems that work out real nice. Well, not all real world problems are going to work out where the x-intercept is an actual just 3. Okay, it could be 3.2 and so forth. Today we're going to start out ones that are a little bit nicer, so that you work on just finding the information rather than worrying about the math. So I'm going to work through example 1, and that one is just actually picking out the information from the graph. So what it says here is the graph at the right shows the height h in feet of a small rocket t seconds after it is launched. The path of the rocket is given by the equation. So t is our seconds, okay? And so that's our time in seconds. And then we have h is our height in feet. And all that did, the first sentence, is give us the information of the story. All we really need to worry about is the equation. But in this case, what we're going to be doing is first we're going to pick it out from the graph, and then we're going to go ahead and find all of it algebraically. So sometimes when we have a graph already shown, we just have to pick out the information, but it's an estimate. So this first question says, how long is the rocket in the air? Well, the rocket's going up right here. It's going back down, and it's in the air for 8 seconds. So that's how long it took for the rocket to reach the ground. What is the greatest height the rocket reaches? Well, that's going to be our highest point right here. That's our vertex. And so the greatest height right here, if I go over, I have to look at my scale. This is 100, 200, and in between I have 20, 40, 60, 80, 300, so this would be 20, 40, 60. So my estimate is 260 feet. After 2 seconds, how high is the rocket? Well, let's take a look at where is the rocket at 2 seconds. Here's 2 seconds. So I follow this up. At 2 seconds, my height looks like it's about right here, and it looks like it could be in between 180 and 200, so I'm just going to say 190 feet. Is the rocket going up or down at that time? Well, if the rocket took 8 seconds to get to the ground, we also have to remember that the axis symmetry cuts it in half, so 4 seconds is going to be the time it takes to get to that maximum height, so 2 seconds, it's still on its way up. After 7 seconds, how long or how high is the rocket? So I go over here to 7 seconds, and up here, and I go over, and it looks like it is 100 feet. And now again, that's past the halfway point of 4, so this is going to be on its way down at 7 seconds, because at 8 seconds, it's already on the ground. At what time does the rocket reach 100 feet? So that's a little bit different question. Now it's asking us, when is this rocket going to reach 100 feet? So here's 100 feet. So I'm going to follow it over, and it reaches it right here and right here. Well, how many seconds is that? It looks like 1 second. And again at 7 seconds. How long does it take to reach its maximum height? We already answered that question right here. It is 4 seconds. And then this is another interesting question. It says, do you think the rocket is traveling faster from 0 to 1 second or from 3 to 4 seconds? So if I look at those intervals right here, and I look at this interval from 0 to 1 second right here. Okay, the rocket from 0 to 1 second, from 0 to 1, it went from 0 up to 100 feet. And from 3 to 4 seconds, so from 3 to 4, that's from, the rocket went from here at 3 to there at 4, so it went from about 240 to 260. So, which one was the larger increase? Well, this is the increase of 100 feet. So this one right here is 100 feet increase. This is only like 20. So that's just kind of an interesting thing to look at, and you can kind of compare it to how we looked at lines and the steepness, and this is a much steeper section of the quadratic. So now that we just picked out the information, you'll do that on your own after we work through this last example here. But we're going to actually take this same problem, this same equation that we had right here, and we are going to actually find those things exactly, because remember, above we were just estimating. So now we can actually use algebra and the equation to actually find that. So it says, how long is the rocket in the air? So again, here's my rocket going up and down. How long is going to be right here? This is the piece of information I want to know. Well, that is one of my x-intercepts. So what I can do here is to find my x-intercept, I can put 0 in here for h sub t. Okay, I can set this equation equal to 0 to find the time when the rocket is on the ground at 0 feet. So I take 0 and set it equal to negative 16t squared plus 128t. Now I'm going to factor. I can factor out, a 4 goes into each, and since the leading coefficient is negative, I'm going to factor out a negative 4t, and that leaves me with t plus, oh, sorry, I factored out a negative 4, so this is going to have to be, I got a little messy, so let me try that again. I'm going to factor out a negative 4t, which is going to leave me with 4t minus 32. Now what I'm going to do is use the zero product property, and I'm going to set each of these things equal to 0. Because the zero product property says if two things multiplied together have an answer of 0, one of them has to be 0. So that means negative 4t would have to be 0, or 4t minus 32 would have to equal 0. So I'm kind of doing this work right here for this problem down here. Well, if I divide by negative 4, then t, the time, is 0. Okay, so that's right here. This is 0 seconds. And now if I solve this one, I'd add 32 to each side, and that would give me 4t equals 32, divide by 4, so t equals 8. So this other point right here is at 8 seconds. So now I can answer that obviously 0 is where it started, so the time it took to get there, back to the ground, was 8 seconds, which is exactly what we set up here. So that part was right on our estimate. So now how long does it take to reach the maximum height? Well, if it got all the way to 8 seconds, then how long it took to get there would be halfway. So actually, if we just use thinking and our axis of symmetry, we could see that this would have to be 4 seconds. But we can actually find our vertex right here to verify. Okay, so we're going to find this vertex right here, because that's going to give us the time and the maximum height. So this is our time and this is our height for that vertex. So what I'm going to do is take the equation, and these two questions right here, I'm finding the vertex. So I'm going to do that down here where I have a little more space. So my x value, or my axis symmetry, is the opposite of b, so negative 128 over 2 times negative 16. So negative 128 divided by negative 32, negative divided by negative is positive, so x equals 4. So my time is 4. Okay, so how long does it take to reach the maximum height? It is 4 seconds. What is the greatest height the rocket reaches? Now I'm going to put the 4 into this equation. So now I'm going to really find h sub 4 and set it equal, and find that value find the y value when our time is 4 seconds. So now when I do that math, I take 4 squared, which is 16, multiply it by negative 16, then add it with 128 times 4. You can plug all that into your calculator, and what that will give you is 256 feet. So we were a little off right here. Okay, we had 260, but we were estimating, and this is why we need the algebra to actually verify and find the exact values. Then the next two questions say after 2 seconds, how high is the rocket, and after 7 seconds. So now on our previous question, we estimated that from our graph. What we're going to do now is we're going to actually find that by finding the height right here when the time is 2. So what I do is, again, I'm finding h sub 2 by plugging in a time of 2 seconds into my equation. And when, again, I just calculate and plug that all into my calculator, and that gives me 192. So again, our estimate was not that accurate. We had 190. But again, we know that if it was the vertex, or the highest point the rocket was at 4 seconds, then if this is at 2 seconds, it's on the way up. And then to do 7 seconds, we do the same thing. We plug in 7 right here. And so we find h sub 7, which is negative 16 times 7 squared plus 128 times 7. And again, when we plug all that in, that is going to give us 112. So 112 feet. And I got a little mistake here by putting this in the wrong blank. This up part should be, but that's going to be on its way down. So hopefully we're trying to tie some of these things together with all the algebra we've been doing to find all the x-intercepts and the y-intercept and the vertex and the axis symmetry. And these are the reasons why, because in real world problems they have some big impact and are some important piece of information. So what you're going to do today is you're going to do this example 2, and you're going to do one more question, and your assignment here is to actually do 1 through 21, which I've already gone through 1 through 12 with you. So in example number 2, follow exactly what we did. You're going to first estimate. So first you're going to estimate from the graph, okay? But then you're going to actually solve. So then you're going to actually solve actual work from the equation right there. So make sure you show your work algebraically on how you got all the information that verifies your estimate was exact or maybe not so exact. So good luck. Feel free to reach out to me via message or Schoology during my office hours, or oftentimes check in at other times of the day. Have a great afternoon.